All right, 8.1.1, we are going to be working with some practice problems. And in 8.1, the notes, we learned about finding the greatest common factor. So the common number and variable that you could divide out from a polynomial. We're going to start the practice problems with distribution. So distribution, we take a number and we multiply it in. And then finding the greatest common factor, we're going to look at the factors that we've been given. So I'll jump down here. We'll look at the factors we've been given and we're going to divide something out, right? And then we have like a number on the outside here. So it's kind of reverse distributing. So we're going to practice distribution and then we're going to do the reverse of that and divide out. So if distributing is multiplying in, then factoring is dividing out. So we have this x squared. It's going to multiply with both of these terms here. So I'm going to do my numbers. So this is a 1x squared. If you need to write a 1 in there, you can. So I'm going to multiply my numbers times my numbers, and then my variables times my variables. So I'm going to do 1 times 2, which makes 2. And I'm going to do x squared times x to the first, which means there are a total of 3 x's, or x to the third. So I have an x to the second power times an x to the first, and those are going to raise up to become x to the third. All right, for my second group, I'm doing 1 times negative 4, which makes negative 4. And x to the second doesn't have anything to combine with over here, so it's going to just stay x to the second. And when you go to type your answer in, remember you're going to hit like the 2 button, and then you're going to hit the X button, and then you're going to hit Shift 6, which is like that little caret. It's like a little arrow. And that's going to make your exponent number for you. So if you do Shift and 6, that's going to give you this little exponent guy. And then you're going to be able to write a 2 in there, right, to the second power. And then you want to hit the right arrow because that's going to bring your cursor back down, and you can write minus 4x. And then you're going to hit Shift 6 again to get your box up here and a 2. And actually, I was so focused on explaining this that I wrote the wrong number here. There should be a 3. So 2x, and then you'd hit Shift 6 to create this like exponent. You hit 3 and then minus 4 and the x, and then Shift 6 again to get to the second power. Okay, so for this one, we're going to take x and we're going to multiply it in. So if there's no number on the outside of this x, then these numbers aren't going to be changed. Think about it. If this is a 1 here, then it's not going to change that 2, and it's not going to change that 8. What it is going to do is it's going to raise our x, the power of x, by 1. So for our first one, we have x times 2x squared, which would make 2x to the third. And then we're doing x times negative 8, which is going to give us negative 8x. And that's our answer. Okay, if I have to distribute on a negative 4, I'm just going to multiply a negative 4 times 9. And that's going to give me negative 36. And then I'm going to do a negative 4 times 8x squared. And negative 4 times 8 is negative 32. And then the x squared isn't being changed at all, so I'm just going to leave it as x squared. So this is, again, just review. So for this first one, we're doing 3x times 7x. So I'm going to do 3 times 7 and get 21. And x times x will give us x to the second power. And then I'm doing 3x times 6. And 3 times 6 is 18, positive 18. And then I'm just going to leave this x attached because it wasn't being raised by anything over here. We just had one of them, x to the first. So it stays x to the first. All right, last couple here. 7x times negative 3. 7 times negative 3 is negative 21. And then I'm going to leave the x attached because there was the x there. And then 7x times negative 4 is going to give us negative 28. And x times x will raise it to x squared. All right, and our final distribution one, I'm going to take this negative 2 and I'm going to multiply it in times 3x to the second. So negative 2 times 3 is negative 6, and my x to the second isn't changing. And then I'm going to take my negative 2 and multiply it to the 10x. Negative 2 times 10 is negative 20, and I leave my x by its how it is because it's not being raised by anything out here. Okay, so that's distribution. That's taking a number and multiplying it in. When we are finding the greatest common factor, we're going to look at what's been given to us, and we want to know what could we divide out of it. In other words, what's the largest number that could go out here in this box that could multiply in to create 9x plus 9. So we're going to look at our numbers, we're going to look at our variables. And for greatest common factor, they have to have something in common. So if I'm looking at this one, I've got 9 and 9. That's my common number. My common number here is 9. Do it in red. And that's multiplying in. I'm going to look here. I have an x here that I could take out, but I don't have an x here. So I can't take an x away because they both don't have one to give. So my greatest common factor is 9. And then I'm going to write what would be left over. So we can do this by dividing. So if I say 9x divided by 9, that leaves me with 1x. And if I do 9 divided by 9, that leaves me with a positive 1. So my answer here is 9 times x plus 1. And if we were to multiply this back up, that's what this would make. So we're pulling the common factor out to tell us, hey, what could this have been before it was this? So let's try another one. And in the notes video, I gave you strategies for how to do these. So like for this one, I have 6 and 16. So if I'm unsure of what number, what's the largest factor I could use, I'm going to take my smaller of these two numbers, and I'm going to list it, 6. And I'm going to list 1 times 6, 2 times 3. And then I'm going to start with my biggest number, which is always going to be on this corner if you list it like in order. And then I'm going to work my way down to the smaller numbers. So 6, 3, 2, 1. So if I compare 6, I'm going to see, I don't need to see if 6 goes into 6. I've already listed that here. I need to see if 6 goes into 16. So 16 divided by 6 will give you a decimal. So that means that 6 is not a factor of 16. 16 divided by 3 will also give you a decimal. That means that 3 is not a factor of 16. And then 16 divided by 2 gives us 8. So I could write that down here. That made 8. If I divide 16 by 2, it makes 8. And then if I divide 6 by 2, I get 3. And so I used a 2 there. So 2 is my number that goes outside. And when I divide both of these by that 2, this is what's left over. And then I do need to remember my variable. So that's going to be x squared. So my answer is 3x squared plus 8. All right. Sometimes we'll have numbers, sometimes we'll have variables in common, and sometimes we'll have both. So this one, we can look here, and we don't have any numbers in common that we could divide out. But we do have, we do have variables in common. So we have a common x, right? And the most amount of x's that I could take out is 1, x to the first power. Because if I take anything bigger than x to the first power, this term doesn't have enough to give. So check this out. I'm going to do 4x to the second, and that is going to drop 1 power. So x to the second is now going to become x to the first. And my 4 isn't changing because I'm not dividing any numbers out. So on my second term, this x divided by x is going to delete itself. It zeroes itself out. 1 minus 1 means there's going to be 0 x's for me to write down over here. But there is a 1 next to this x, so I have to leave a 1 in my answer. Just remember, if we were to multiply this up, x times 4x to the first would make 4x to the second, and x times 1 would make 1x, and that's what we started with, okay? So we're reverse distributing. So my answer here is x on the outside, and then 4x plus 1 on the inside. Okay, same idea here. We don't have any common numbers, but we do have a variable in common. The most amount that I can take away from both is just this 1x. So on the outside, there's a 1x I can take out, and that's going to drop the power of x's here by 1. So this is going to become 7, and x and x erase themselves. And then minus x to the second, and I'm dropping it 1 power, is going to become x to the first. So our answer is x times 7 minus x. The check is, if I were to multiply these back up, I do get my original problem. Okay, so these aren't so bad. What happens if we have x to the third? Well, I'm going to check. I don't have common numbers that I can divide, but I do have common x's. I have an x here and an x. I have 3 x's here. X to the third, that's 3 x's multiplying, and x to the first, that's 1x multiplying. So I can pull 1x from each of them. There's 1x in common, and that would leave me with 2x to the second, remember, because we're going to drop a power from pulling this one out. So 2x to the second minus, we don't have, these x's zero each other out, so we're going to have no x's written there, but we will write a 1 because this is 1x. So our answer is x times 2x squared minus 1. And again, if I were to take this and multiply it back in, I would end up with my with what I started with. Okay, and then 16 and 40. No common x's here, so I don't have to worry about that. So I'm going to look at, I do have numbers. So I'm going to see if there's what the greatest common factor between them is. So I'm going to list the factors of 16. I have 1 times 16, 2 times 8, 3 doesn't work, 4 times 10, and 5 times, oh, sorry, I started thinking 40. That was my bad. I'm doing 16. Okay, so 1 times 16, 2 times 8, 4 times 4. I started thinking about the factors of 40, and I didn't want to do that. I only want the factors of 16 here. So now I'm thinking 16. Will 16 go into 40? So on your calculator, if you do 16 divided by 40, you get a decimal. Doesn't work. Okay, how about 8? Does 8 go into 40? 40 divided by 8 makes 5. So 8 is our greatest common factor. So if I were to divide out an 8, 8 is going to leave me with 2 for my 16. So there's a 2 left over here. Plus 40 divided by 8 makes 5. So 5x. So my answer is 8 times 2 plus 5x. So we've divided out the largest possible number that we could take from both of these.